Hi, welcome to a quick introduction to Apache Spark. This is a quick start video providing a very basic overview of what Apache Spark is and the kind of scenarios that you might want to consider using Apache Spark. The video itself assumes no prior knowledge of Apache Spark, but if you have some familiarity with data processing, business intelligence, or even Hadoop-like environments, that can help, but absolutely not a mandate for this video. So it's really a quick introduction video. So in this video, we'll take a look at some of the building blocks of Apache Spark. So what is Apache Spark? What are the building blocks of Apache Spark and a high-level architectural view of what are the distributed components of Apache Spark? So basically, Apache Spark is a fast, really quick, high-performant distributed cluster computing system. Now, those are some keywords that come into play when you're thinking about big data and large-scale data analytics. So unlike other data processing systems like Hadoop, Apache Spark is really much faster in terms of the computation as well as how it utilizes resources such as memory to perform a lot of iterative computations. It is general purpose in the idea that Spark is both suitable for doing batch-based processing as well as real-time processing. So if you didn't use Apache Spark, chances are for batch-like processing, you would have had to use a framework like Hadoop and MapReduce in Hadoop. And for doing real-time processing, you may have looked at other frameworks like Apache Storm, for example. Whereas with Spark, you can actually do both. I mean, it gives you the flexibility and a single unified framework, if you will, and programming approach to handling both batch-based as well as real-time. So again, it's a very powerful combination of using one single product or framework to address different kinds of data processing needs, be it ETL-like or analytical style workloads. And again, just keeping in mind that Apache Spark is really intended for large scale data processing. So if your data basically fits into the remit of a single large server, then of course Apache Spark might not be that optimal. It really shines when you have huge volumes of data. Fundamentally, if you have like a big data kind of like a challenge, then Apache Spark is definitely a contender. And then finally, in terms of the programming experience itself, Apache Spark has been built on top of Scala, the programming language. So it's basically runs on a JVM. However, if you did want to program for Apache Spark, so Scala becomes a good choice there. I mean, the code is very elegant, thanks to Scala being a very modern programming language with its various functional programming constructs. It makes programming in Spark fairly straightforward. However, if you come from a Java background, you can code in Java as well, and Python becomes a first-class citizen. So a lot of data scientists and members in the community, they're very familiar with Python as a programming language, so it's easy to get started with Python. And finally, as of the introduction with Apache Spark 1.4, R is also a supported programming language and increasing momentum in terms of the broader community using R and Apache Spark together. Keeping in mind that Apache Spark normally, I mean, it's this block here is what's referred to as a core, the Apache Spark core, and that's the core framework which allows for a lot of the magic to actually happen within Apache Spark, which we'll cover in the next two slides. But on top of Apache Spark, as part of the libraries, you have a few other capabilities worthwhile highlighting. So it comes with Spark SQL. So Spark SQL allows you to use SQL-like constructs or query constructs to query structured data. And that structured data could be in a CSV file, it could be a JSON file, it could of course be in a SQL-like repository. So again, it gives you that ease of programming with various types of structured information. And then we talked about Spark streaming. So it's really intended if you're doing real-time or close to real-time processing. Keep in mind that it's not a true real-time processing system like Apache Storm. It uses what's referred to as micro batching, but basically it gives you very, very low, the latency is not too bad, but it's not a true real-time system. But for 95, 99% of the scenarios, micro batching would suffice. Spark also comprises of a machine learning library, so that's one of the areas that Spark really excels in terms of its use of memory and the underlying implementation for iterative algorithms. Again, very, very suitable for doing machine learning like tasks. And finally, you also have the GraphX. So if you want to do graph processing and computation related to graphs, Apache Spark gives you a framework to do that kind of processing. So that's kind of like, if you will, the Apache Spark in a nutshell. Looking at some of the concepts and terms that come into play, particularly if you're looking to develop Apache Spark solutions, you're either a developer slash architect or a technical person. Um, these are some of the constructs that you will come across as you dive into Apache Spark. The magic of that distributed processing and how it manages that data and the transformation of that data, which we'll talk about in a bit, is entirely managed through the Resilient Distributed Dataset, or RDD. And that's where Spark does most of the handling in terms of the transformation and managing the data lineage. So that's something which we'll dive into detail in future workshops and future videos. You have what's called as the direct acyclic graph. So essentially what happens is when you run an application within Apache Spark, it basically constructs a graph comprising of nodes and edges, and it basically forms that sequence of computation, if you will, that needs to be performed on the data. Where basically you have this large graph-like model. So again, you have nodes that would typically be mapped to RDDs. So it basically constructs that execution flow, if you will. And that's really the magic behind Apache Spark, as opposed to the Hadoop-like environment, which entirely depended on MapReduce. You have what's called as a Spark context. I'll highlight this in the next slide, but essentially the program, you have something what's referred to as a driver, and the driver instantiates the Spark context, and the Spark context does a lot of the orchestration, if you will, or manages the orchestration within a Spark cluster. The next concept is about transformations. So it'll become clearer once we step through some of the other future demos. But essentially, when you load data, say for example from a data store, it could be like a CSV, and you load that data into an RDD. RDDs are basically immutable, so you can't change that. Once you perform an action, once you perform a certain activities on an RDD, like say for example, if you were to do a filter or if you were to do a map like operation, it creates a new RDD, and that's collectively what's called as transformation. And then finally you have what are called as actions. Now, anything within Spark, keep in mind, is done through a process of lazy loading. That basically means that when the DAG is created, it does not actually do any form of computation or execution of the underlying data till it's actually required. So it's almost like a lazy load process, and that has a lot of benefits, in part because that allows for some form of resilience, if you will, within this whole RDD and the DAG model. So that only when somebody requests for the actual data does it actually need to do all the processing. So it's almost leaves processing towards the very end or just as and when needed. So if you're extracting data, like if you're trying to collect the data, get counts, etc., these are all what are referred to as actions. So again, keep in mind that transformation, if you think of a flow, a process or a sequence of events within Apache Spark, it comprises of many transformations and few actions that ultimately result in the underlying the logic, if you will, being implemented in Apache Spark. And finally, the last thing we'll take a look at in this video is really about a high-level view of the various Spark components. So Spark, as you may recall, is a distributed computational engine. So it does need to cater for that high performance computational model as well as resilience and fault tolerance. And the way it addresses that is using a couple of constructs. So one, we have what's referred to as a driver program. So if you've started Apache Spark in the Spark shell, the Spark shell becomes your driver program. Otherwise, if you've written an application, say in Scala or Java, basically the program that runs it, basically the entry point, which is the main function, actually creates what's referred to as the Spark context. And the Spark context really allows for communication and coordination with other nodes within your cluster, what's referred to as a worker node. Now, within the worker node, you have what's referred to as an executor. The way you can think of it is anytime you run an application, a Spark application that is, it'll create a different process within worker node. So every application, a Spark application is running within its own executor. So a worker node will have many number of executors. And within the executors, you may remember, as we discussed within the Spark model, so you have the DAG, which constructs the graph, which is then broken down to stages and tasks. And these individual tasks are then run from within the executor. Now, before the actual Spark application runs on the cluster, of course, the Spark context or the driver program in this particular case communicates with the cluster manager. Now, Spark has different cluster managers that you can utilize. So you have an out-of-the-box Spark cluster manager itself, and that's the simplest one. And since it's available when you install Spark, it tends to be the default for a lot many development, testing, and even quite many number of production environments. However, you can replace that with Yarn or even Apache Mesos as a good cluster manager. So again, both Yarn and Mesos give you other more advanced cluster managing capabilities, like putting stuff into a queue, for example. But for a lot many of the cases, and particularly to begin with, you can use the out-of-the-box Spark provided cluster managing capability. So that's a quick overview of Apache Spark. So we have taken a look at what exactly Apache Spark is, and some of the keywords, if you will, or the building blocks of Apache Spark, and then finally a very high-level view, if you will, of the distributed nature of Apache Spark. And in future videos in the series, we'll cover a lot of these in more details and do some hands-on demos. Hope you liked the video and look forward to seeing you in other videos in the series. Thanks for watching.